that this angle across from x is also x degrees. Why? Giselle? They're vertical angles, okay? Now, does anyone remember how to figure out what an exterior angle is equal to? Emma? Add the non-adjacent interior. So y equals x plus 60. The answer choice was then A. Okay? Now, when I did this problem the first time, I did not do it like this. Okay? And I want to show you how I did it. Okay? I did it by saying, okay, this angle right here, right? This double angle needs to be equal to 180 minus what?
60.
Minus 60 minus x, right? Because inside this triangle, there's 180 degrees, right? We subtract 60, we subtract x, that'll give us this angle. What's 180 minus 60? So this is equal to 120 minus x. Agreed?
That's what I thought.
Okay, now this whole thing creates a straight line. Do you agree? So those two angles must be supplementary, 180. So 120 minus x plus y equals 180. These two angles added together must equal 180, okay? Now, the way I did it was a lot more confusing, okay? But bear with me, okay? All right, so now we're solving for y in terms of x, so we got to subtract 120 from both sides. We're going to get negative x plus y equals 60. And then what do we do to solve for y? Add x. Y equals 60 plus x. Cool beans?
Wait. Yeah.
So guys, these questions, I know we did them a long time ago, okay? But they are SAT style questions. I want you guys familiar to the types of stuff they're going to be asking you, okay? Yes. All right, before we get started with today's lesson, I want to take any questions from 7.3's homework. What else do we know about parallelograms? Emma. Love it. Opposite angles are congruent. I'm going to use the congruence symbol. What else do we know about parallelograms? Emma, go for it. Love it. Opposite sides not only are parallel, but they're also congruent. Guys, does opposite have two P's?
Yes.
Oh, wow. Opposite. I'm a math teacher, not a science teacher. Sides. Why did I? English. Are congruent. What else? What else? There's at least two more. Giselle.
Hold on, I just wrote this down. No, please don't. False. Okay. Adjacent. No, I didn't write it. You can false. Non-adjacent angles. Adjacent.
Are supplementary. Okay. Now, you might also, instead of adjacent, say that they're consecutive. And all those two mean is just that they're next to each other, not across from each other. Christian, what else do you know?
I forgot what it's called, but when you get a line from like the corners, it bisects.
Very good. What do we call that line from the corners, people? A diagonal, okay? Ugh. Diagonals. They do what to each other? Bisect each other. What else do we know about parallelograms? I feel like that should be it. 1, 2, 3, 4, 5, 6. Yeah, that's it. Yeah. A stylus? There might be one on my desk. You can check. Okay. Now, all of these things, only some of them are enough to prove the reverse. Okay? And today, that's what we're going to see. We're going to see which of these properties, if we have it in our quadrilateral, will prove that it's a parallelogram. Okay? So, the first one states the opposite sides converse. Okay? So this converse says if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Okay? That means if you can prove that there are two pairs of opposite sides and they have congruence, you're dealing with a parallelogram. Okay? Now remember, the way I remember is the converse. You're not given it's a parallelogram. You're proving it's a parallelogram, okay? The regular theorems, you're given it's a parallelogram. You can prove the congruence and the consecutive stuff. Yes?
Did you start the Zoom? I think Sammy's trying to get in.
I did start it. She wasn't on time. So I can't add her now. Okay? All right. Questions on this first converse theorem? Next converse theorem. Opposite angles converse, okay? So if there are opposite angles and they are congruent, that is enough information to prove that it's a parallelogram. Yes. So it says if one pair of opposite sides of a quadrilateral are congruent and parallel, then the quadrilateral is a parallelogram. It has to have and, okay? They have to be congruent and parallel. But it's only one set. If you can prove one set of the sides is congruent and parallel, it is automatically a parallelogram. Converse. So remember how we said for a parallelogram, if the diagonals bisect each other, the diagonals do bisect each other, okay? If you're given only that the diagonals bisect each other, then you can assume that it is a parallelogram. It works in reverse. There are 5 ways to prove that a quadrilateral is a parallelogram, okay? Based on those 5 theorems. You can either show that both pairs of opposite sides are parallel. That is called the definition. Okay? That's the definition of a parallelogram. You can show both pairs of opposite sides are congruent. That's opposite sides converse. You can show one pair of sides are parallel and congruent. That's parallel and congruent converse. Regular theorem. Because that one never had an original theorem, okay? You can show both pairs of opposite angles are congruent. That's opposite angles converse. And then number 5, it shows the diagonals bisect each other. That is the diagonals converse. Okay? Oops. State the principal definition or theorem that enables you to deduce from the given information that the quadrilateral is a parallelogram. Okay? So, we're using the same parallelogram for the same quadrilateral for each of these, but we have to figure out which definition or which converse or theorem we can use to determine that this is a parallelogram. If BE is equal to ED and CE is equal to EA, what theorem could we use to prove that it's a parallelogram?
Diagonal theorem converse.
Very good. Diagonals converse theorem. Diagonals. If I could spell, diagonals converse theorem. Now let's explore why we use that theorem, okay? BE is this one, right? And that's equal to ED. So those two are the same length. And then it says EA is the same length as EC. Do you guys agree that this is the only theorem we could use to prove that this is a parallelogram? Okay? Number 2, angle BAD equals angle DCB, and angle ADC equals angle CBA. Well, let's go ahead and fill that in our diagram. BAD is right here, this angle. So let's put a mark there. And that one is equal to DCB. And then it says ADC, which is this one, is congruent or equal to CBA. What theorem with just the red marks on our diagram could we use to prove that it's a parallelogram?
Opposite angles then?
Opposite angles theorem. No.
Converse.
Opposite angles converse theorem.
Wait,
There we go.
what? So if the angles aren't there, it's regular?
Mm-hmm. Well, think about what we're proving, right? What are we proving right now? We're proving that it's a parallelogram, right? If they tell you it's a parallelogram, use every single regular theorem. If you're ever proving that it's a parallelogram, you're proving it's a parallelogram, you have to use the converse, okay?
I think you just repeated.
If you're given, did I repeat myself? If you're given that it's a parallelogram, regular theorems.
Okay.
If you're proving it's a parallelogram, all the converse.
Okay, so if there's no marks, it's Converse.
No.
No.
If there's no marks and it says it is a parallelogram, then it's the regular theorems.
Oh, okay, so just
Okay.
have to prove it.
Yes.
Okay.
Mm-hmm. So in order to use the converse, you need to be given something, okay, on your figure or in the wording of the problem.
No marks and given?
Wait, no, that was wrong. The
Okay,
marks-
moving on. Guys, I'll try to answer all questions at the very end. BC is parallel to AD, and AB is parallel to DC. Very good. This is just the definition of a parallelogram. Okay? The definition of a parallelogram says that it needs to have two pairs of parallel sides. So that's just the definition. What if BC is equal to AD and AB is equal to DC?
Opposite sides converse.
Excellent. This is the opposite sides converse theorem. Yep.
When it comes to the test, say we opposite sides theorem, but we forget the converse, do we get partial credit or no?
I think you should.
Probably not. Converse, okay? This one is just parallel and congruent theorem. There's no converse here, okay?
Why is there no Converse?
Because this was never a regular theorem to begin with, okay? Correct. This is a brand new theorem that we didn't learn in the last chapter, or the last section, okay? This is the parallel and congruent theorem.
So for this one, even if you have to prove it, there's no Converse.
Correct. Questions on this one? Yeah, Jaden.
The parallel congruent theorem is like really similar to like opposite sides.
It is. It's a combination of both opposite sides parallel and opposite sides congruent. Okay? But it's only saying that you only need one pair of opposite congruent and parallel. Okay? All right. For what values of x and y is the quadrilateral Pqrs a parallelogram? What do you guys think we should do here? Giselle?
X plus 9 is equal to 2x minus 1, and then y equals x plus 7.
How'd you come up with those?
Because, hold on, let me find it. sides converse theorem
Very good.
says that the opposite sides of the parallelogram have to be equal.
Correct. Okay? In order to prove that this is a parallelogram, the opposite sides converse theorem would need to be applied. That says that the opposite sides PQ and SR would need to be congruent, and PS and QR would need to be congruent. So we have two different equations. Which one do we start with? The red equation or the yellow equation? Savannah? Go ahead.
If it says it's a parallelogram, so how do we prove
It doesn't say it's a parallelogram. For what values of x and y is the quadrilateral a parallelogram? Okay? It would say specifically PQRS is a parallelogram and then go from there. Those would be the regular theorems.
Alright.
Got it? Okay. Guys, which one should we start with?
X, yellow, X.
Emma? The yellow one. Why can't we start with the red one?
because for that equation we need to know what x is.
Very good. We don't know what x is yet, do we? Do you see how yellow only has x? We need to start with that one in order to figure out the red one. So let's solve the yellow one. What would I do?
You can add 1.
Add 1 to both sides. Love it. What do you get?
Oh wait, no, you have to subtract.
Subtract what?
No, because you have to switch the sign.
No, that's right. You're right. You add 1. But what do I get after that? These are going to cancel.
And then,
She said 10.
wait, it's 10.
Yeah, 10 equals 2x. Then what? Jaden?
Subtract that.
There we go. We subtract x from both sides. So we're going to get 10 equals x. What do I do with that?
Because you know how one method switch change to the opposite side.
Yep.
To change the sign. So I did -1. I went to -1 to the other side, so that I would have to.
No, so you did it right. You used the opposite of this minus would be adding. So you added 1 to both sides. You set it up the right way.
I know. I don't
Okay.
know why I did that.
And then we take that 10, we plug it in. What do we get for the red equation? Y equals 17. Y equals 10 plus 7, which is y equals 17. Cool beans? Okay. Now, if this example was given to you just like this, I don't expect you to write this theorem, right? But if it said explain, I expect to see this theorem, this converse theorem. You guys got it? So if this question was given like this, you don't have to write that theorem. Okay? It doesn't say explain. It just says what values of x and y. Is this a parallelogram? Okay? But if it said explain, I need that theorem. Got it? Okay. Which one?
How do you get, because it says x plus 10 equals 2x, and then you subtract x, and then you become
Okay, because remember 2x minus x, this x has a 1 in front of it. And it's just 2 minus 1, so you have 1 x left over. Make sense? Yeah. Example 3. For what values of x and y is the quadrilateral a parallelogram? Giselle? What's that? Okay. For this one, how do we do it? Mariana? Opposite angles converse theorem. Okay, so the opposite angles converse theorem says that if they're opposite angles, they must be congruent. So what are my two equations? Jaden?
3x minus 32 is equal to 2x.
Yep.
And y plus 87 is equal to 4y.
Love it. All right, someone walk me through solving the red one. Giselle, go for it.
So first you have to add 32 to both sides.
Okay.
So after you add 32 to both sides, then you have 3x equals 2x plus 32.
Good.
And then you have to subtract 2x from 3x.
Yep.
Or 2 from 3. Yeah, 2x equals 3x. And then, yeah, minus 2x, and then you have x equals 37.
Perfect. And the black equation? Gabby?
You can subtract x from both sides and then divide 87 by 3.
Yep. What's 87 divided by 3? Well, let's do it. 87 divided by 3. 3 goes into 8 how many times? 2 minus 6. You have a 2 left over. Bring down your 7. How many times does 3 go into 27? 9 times. So this is 29. Okay, last example, peeps. Last example.
Wait, so it's opposite.
Excellent. If we have opposite parallel sides, so if we can prove that this is parallel to this, and this is parallel to this, then we're golden, okay? What else could we do to prove that it's a parallelogram? Savannah?
You can be difficult and like find the distance formula.
Find the distance. We could prove congruence between AB and DC, and also BC and AD. I do not recommend this because that involves the distance formula, okay? What Gabby said, which was proving that each of the opposite sides are parallel, is the easiest method, because that only involves slope. But how else could we prove that this is a parallelogram? Giselle? The angles. Now, we haven't learned how to find out the measure of the angle from like a coordinate plane like this, but yes, you could use the opposite angles theorem. What else? Technically, what if I drew two lines like this? You could find the distance between half of the diagonals, make sure that they bisect each other, the distance between these two, okay? But that also would involve the distance formula. I don't want you doing it that way. And the last way you could do it is using the distance formula, prove that two sides are parallel and congruent, okay? Prove that two sides are parallel and congruent, okay? If you are given any option to use, my recommendation is use this one, okay? So how do we prove that AB is parallel to DC? Let's write that one down. Let's prove that AB is parallel to DC. What would we do? Anna? Find the slope. What's the slope of AB?
1. Well, it's
Plus 2 over 1, 2, 3. I counted 5.
yeah.
So what's the slope? Okay, slope of AB is 2 over 5. What's the slope of DC?
2 over 5. I mean,
Plus 2 to the right 5, so plus 5. So the slope of DC is 2 over 5. Are they parallel?
mm-hmm.
Yes, parallel. But that's not enough to say that it's a parallelogram. What else do I need to prove?
AD and BC.
Excellent. We also need to prove that AD and BC are also parallel. Okay? What is the slope of AD?
Oh,
Gabby?
negative. Positive 3 over negative 3. Or negative 3 over positive 3.
Yeah, negative 3. We went down 3 and then to the right 3, so positive 3. So the slope of AD is negative 3 over 3, which is just negative 1 when you simplify it. What do we compare that to? The slope of
BC.
BC. Excellent. So the slope of BC, we're going down 3 minus 3, and then to the right 3 plus 3. So the slope of BC is also negative 3 over positive 3, which is just negative 1. Are those slopes the same?
Mm-hmm.
Yes, so we say that they are parallel. So if you're given the option to pick any method that you want, I recommend this one, okay? Because it's the easiest. You can just show the slopes are all the same for two pairs of opposite sides. All right, this is where we're going to stop. Go ahead and turn in your notes. Yes?